Hello, hi everybody. Assalamualaikum. So now I'm going to do a very short videos, but this is actually an applications of how we apply the knowledge of ocean gyres and big current circulation system into what really happened in the world. So one of the very interesting topic is ocean garbage patch. So ocean garbage patch is basically scientists figure out there's lots of ocean garbage which is plastics and microplastics happens to be in the middles of ocean gyres. Why it happens in that way, how it goes and stays there for accumulate over there. So that's where physical oceanography can describe. And I also have one very interesting examples. Remember what happened to MH370? So 6 years ago, I was involved, not much, but as a team, research teams, we involved in doing some numerical modelings and simulation for ocean currents. I'm going to give you some description on how ocean gyres and ocean current system can give us a very important information on searching for MH370 debris in the Indian Oceans. So this is two examples that I'm going to give, and I hope that you can get some idea on how these ocean currents can actually give some not some but actually a very important tools for us to understand what actually happens in the real world. How actually ocean gyre accumulate all this garbage that produced by humans. So this is a very interesting things. So we're going to look at the North Pacific Ocean for an example. So in the North Pacific Ocean, we understand that we have a ocean gyre. So this ocean gyre move clockwise. So you have basically water moving here in the California, and then water moving up in the Japan area. So you have this big ocean gyre. So what happened is most of this accumulation of garbage comes from the land. So all of this garbage move out from the river and then goes into the oceans. So when it comes into the ocean, so they follow all of these ocean currents because garbage and plastics are very light. So they follow ocean currents, and in the end, after a few years in the ocean, so they will end up in the middles of this gyre system. So because in the middle of gyre system, you have a very limited amounts of current movement. So the main current move at the boundary, at the eastern boundary, at the western boundary. So at inner sides of this gyre, you have basically a very slow moving current. So most of this garbage will accumulate at this area. So similar, now they found that there is also a huge amounts of plastics in the near Japanese area. So there you are. So garbage patch is actually an accumulation of microplastics or plastics or garbage in the oceans because of the movement of the current. So they will accumulate in the middle of this gyre. So it's like, you can do this easily you take a bowl or a bucket of water, and then you put some plastics, small plastic into the bucket, and then you try to stir the basket with a stick. Now you can see this plastic will accumulate in the middle. So these similar things happens in the ocean gyre. So scientists, what scientists do is they try to run global ocean models to get to understand how this current system can actually accumulate plastics. So for example, this some of the results that scientists get when they try to run plastics into the system, and then they try to get the data. So they can see that if there is a plastic, so you can see accumulation of this plastic will be in the middle of the gyre. So this is North Pacific and South Pacific, and you can see this basically in other ocean basins as well. One example, very interesting example, in 2010 they have a huge scientific cruise. They collect ocean, they try to do collection of these plastic samples. So you can see that the blue color, So this is the track of the ship. So all of these are ship tracks. So what happened is blue color means there's a very little amounts of plastics that they can get. But suddenly when they cross the ocean gyre, you get huge amounts of plastics. So big numbers of plastic in this middle of the gyre. So I mean, there you are, lots of plastics accumulates in the middle of this ocean gyre. So in the end, this is what scientists suggest. Most of these ocean garbage patch are very huge. So most of these ocean garbage patch is very huge. Some of the garbage patch is as big as the size of 10 times of Malaysia. So you can imagine how big it is at only one ocean basin. So just imagine if you have all ocean basins, you have all this garbage patch. It is very huge amounts of plastics in the ocean. So there you are. We by understanding ocean currents, so we can somehow understand how these currents accumulate plastics. At least it gives us some idea on how we can apply our knowledge of ocean currents by understanding what happens in the world. So let's move to the next case study. So the case of MH370. So I'm not sure. Probably you are still in the school when this tragedy happens. So we don't want to talk about all this speculation where the MH370, but based on our scientific understanding, so MH370 crashed in the southern part of Indian Ocean area, not far from Australia. I mean, Australia is the closest. It is actually very far, about 3,000 kilometers from the closest town in Perth. All right. So this is the search area. So you know what happened after 17 months of searching? So they found there's not many clue that we get from MH370. So what happened is after 17 months, almost 1 year and a half, they found a debris in Reunion Island. One they call it flaperon. One something coming from the aeroplane's wing. So what happened is, people try to lots of people get confused. How can something that crashed over here move about more than 12,000 kilometers away and then being found after 1.5 years in Reunion Island? So nothing has been found along the Australia beach, or maybe Indonesia, but suddenly something appear in Reunion Island. It doesn't make sense at all. But for marine scientists, for people who understand ocean gyre, ocean currents, that is very much possible. A movement in the ocean is very slow. The current in the ocean is actually very slow. So to move from this area to this area exactly will take you. If the things is just floating, it will take you about 1.5 years. So that's what actually happens. So how we know it can move in 1 year and a half? So we have these simulations. So this simulation is very interesting. So this is some collaboration study that we do in UNT with our partner in Australia. So what we do is, ocean simulation. They try to produce the real what happens, what the real thing happens in the oceans. So what we do is we try to put, we call it drifter. If you can imagine, drifter is something like you put a bottles or the yellow duck into the oceans, and then we try to look at and simulate how these yellow ducks move for a certain period of time. So in this case, we try to run for 2 years. So you can see how this we put about 5,000, if I can say, imaginary yellow ducks in this area, the search area. So these 5,000 yellow ducks will move according to the computer simulations, and these simulations actually try to simulate the real ocean currents based on the time scale that we have from the time the MH370 crash on the 8th of March. So let's have a look how this drifter move within those time period. So there, so you can see it moving. So we understand that gyre system moving into this direction, right? But in the real oceans, of course, the movement is not straightforward. So there's always a meanders, moving around. But the average movement will still move to those uh, intended area, as we understand. So you can see by July 2015, something's already arrived at the Reunion Island. So that's how we understand how this debris can actually reach there. So this is the work of a scientist. So that's how we try to understand and use science to understand what really happens in the real world. So there you are. I think that's a very good example, an application that so that you can understand how actually we can apply the understanding of ocean gyre to the real world. So I hope that you can, you appreciate why we study ocean gyre, not only to understand how the current move, but also in the real application of ocean garbage patch, and also something similar, something which is very much important, like MH370 searching uh, effort. So thank you very much. I hope you enjoy the topic. See you again next time.